In this video, I'm going to be going over how to interpret the graph of a quadratic. If you notice, for example 1, I've already graphed the function for us because there are a lot of other videos that will go through in depth how to do that part. So if you're still confused about graphing, make sure you go back and check those videos. But I'm going to start with the graph, and I'm going to start with question B. So it says, what do the x-intercepts mean in context of the problem, and do they both make sense? So anytime you're answering questions in the context of the problem, I think it's always really important to just refer back to what x and y represent for the problem itself. Well, this problem says the following expression represents the height of a ball as it travels over time. So height of the ball, because that's what the expression represents, that is our y value. And then as it travels over time, that is our x value. So our x, y ordered pairs can really be thought of as time, comma, height. I'm running out of room here. Let me rewrite that. It's the same as time, comma, height. So anytime I interpret a problem, I'm always going to come back to that right there. So for this one, we've got our x-intercepts. One of them is at 3, 0. The other one is at, I didn't plot that exactly. 1, 2, 1, 2. It should be at -1, 0. So what do these mean in context of the problem? So if I relate 3, 0 back to this time, comma, height, it really means at time 3 seconds, the height is 0 feet. So at time 3 seconds, so after 3 seconds, the ball is 0 feet above the ground. Well, what does that actually mean, 0 feet above the ground? That's when the ball is on the ground. So the x-intercepts, what do they mean? Well, remember, that's when y equals 0. So they mean when the ball is on the ground. But we've got two of them, and do they both make sense in the context of this problem? No, they don't. The second one does not make sense. Why might that be? Well, because it's negative, and time can't be negative. So what types of numbers do not make sense? For the x values, which is time, we can't have negative values. Because there's no negative time. Oops. And then for the y values, which is height, again, we don't want negatives because there's no negative height. You can't go past the floor. All right, part D says, what is the y-intercept and does it make sense in the context of the problem? Well, looking at the graph, I can see that I have a y-intercept at 0, 6. Again, let's go back to our context coordinate. I'm going to call this the context coordinate. So if I'm going to relate 0, 6 to my ordered pair context coordinate, that would be at time is 0, height is 6. Okay, so at time 0, height is 6. What does time 0 actually mean, though? Time 0 would be when it starts. No time has passed. So it represents the starting point. Specifically for this problem, what this means is that the ball starts 6 feet above ground. So maybe you're holding the ball over your head before you throw it. The ball is 6 feet above the ground when it starts. All right, does this graph have a maximum or minimum point? Looks to me like it has a maximum point. And then what does this point represent? So the point itself is 1, 8. That's our vertex. And again, relating it back to our handy dandy context coordinate up here, that's 1, 8. So at time 1, height is 8. So at time 1 second, height is 8 feet. So I'm going to say at 1 second, the ball, it reaches a height of 8 feet, but specifically, remember, this is the maximum. So the ball reaches its max height. Oops. Of 8 feet. All right. Part F says, given the context of the problem, what would be a reasonable domain? Remember, domain is x values. But back up at part C, we said that for x values, it doesn't make any sense to have negative time. So let's look back up here. If I don't want negative time, that means that I do not want anything to the left of the x-axis. All of this is bad because that's all negative time. This is all what we do not want. But we also remember that we don't want negative height either. Negative y values are also bad. So all of this is also bad. We do not want that. So we really are just focused only in the first quadrant here. And that is just this section of the graph. So we're going to write the domain for only this section here. This section of the graph. I'm going to do it right here, and then we can always rewrite it, the notes later. Domain is the x values. So based on only this small section, what is the smallest value of x? Well, we start right here at x equals 0. So the domain starts at 0. And then what's the highest value of x? What's the last time on this graph? So it goes all the way up to 3 seconds. It stops at 3. That's when it starts to get negative. So the domain is from 0 to 3. Range. Now range is y values. Y is from low to high. It travels from low to high. So the range starts down here at 0. Maybe you couldn't see when I said it starts down here. The range goes from here and then up to our maximum point, which is at y equals 8. So there's our domain and range. These are what we call reasonable domain and range because they're what makes sense reasonably in the context of the problem.